is the first step to develop measures for its closure. Assessing the effects of climate change on crop production and to develop adaptation and mitigation measures is a major challenge to maintain and improve human food security. Actually, the current yield production worldwide does not fully explore the potentials. There are estimates that in many regions the attainable yields which are achieved, that only less than 50% of the achievable yield is really got from the fields. The present annual increases of food productions are substantially less than that what I mentioned before, and range presently for major food crops between 0.9 for wheat and 1.64% for maize. Moreover, when we look at many countries, yield increases of major staple crops are declining over the recent years. Crop models are valuable tools to assess the potential yields and yield gaps under various climate conditions. While in the conventional way, we start from bottom up, from average farmers' yields, and look then at differences to better managed experimental fields, for example, to estimate the yield gap. With simulation models, you go the other way, top down. You start from potential yields, modeling what could be achieved if there is no limitations by water, by nutrients, or any other limiting factors like pests and diseases, weeds, and so on. However, models are normally highly suited for these optimal management situations, but they rapidly lose their value when complex yield limiting and yield reducing factors occur that provoke a wide range of remedial management. So such yield gap aspects almost never feature in models. One example to assess yield gaps is the approach of the Global Yield Gap Atlas, which combines local knowledge from the countries and data with appropriate crop models using a uniform protocol over the world. The main idea is to define these production levels. First, the potential yield, which is solely determined by radiation, temperature, CO2, and the cultivar potential. Then the water limited yield, which would be the normal situation in non-irrigated agriculture, which additionally considers rainfall and the soil buffer capacity or water holding capacity. And comparing these two, the first one for irrigated agriculture, the second one for the rain-fed agriculture, gives us the yield gap, the potential yield minus the achievable yield, which is, of course, influenced by many other factors, for example, poor fertility, nutrient deficiencies, insects, weeds, and diseases. And when you have a look on the website of the Global Yield Gap Atlas, you see that there are already many countries included now, and you can see there the estimation of yield gaps for different crops. The protocols in the Yield Gap Atlas are defined to meet data requirements which are adapted to what is usually available, even in developing countries. So you first have to identify the target group,